Hello, this is Mr. P, and today we're going to be talking about arithmetic sequences. A sequence is arithmetic if the difference between consecutive terms is the same. In other words, if we look at this particular sequence, then to go from A1 to A2, we're going to add or subtract something. And then to go from A2 to A3, we're going to add or subtract the same value. And then A3 to A4, add or subtract the same value, etc. Or in other words, if you were to take the difference between A3 minus A2 or A4 minus A3 between any two consecutive terms, then you'll find out that these differences are again the same value. And we call that number the common difference. Now there is a way to find the nth term of an arithmetic sequence, and it's given by this formula here, which most textbooks use this formula, where a sub n is the common difference times the n being the nth term, plus some number c. And c is defined to be the first term minus the common difference. And that is a perfectly valid formula that works well in many textbooks. I prefer the version that is a little more intuitive. This is the same idea, but it's laid out in a little more intuitive way. In other words, a sub n, your nth term, is simply your first term plus n minus 1 differences. So if you can envision 1, 2, 3 being your three numbers, then to go from 1 to 2 you add 1, to go from 2 to 3 you add 1, but to go from 1 to 3 you would add 2 of the differences, 2 of those common differences. So since we have three terms, there's actually n minus 1 differences because the differences go in between the consecutive terms. And I find this way a little easier to visualize the structure of these sequences when I use this one. Now, as we said before in a previous lecture, any sequence that can be written with a general term can also be written recursively. And the idea of recursive is that we can define the term, the next term, in terms of a previous term. Whereas with the nth term, you can go directly to the 100th term. For example, if n is 100, you can go directly to the 100th term as long as you know what the initial term is and what the common difference is. But recursively, we can say that the next term, a sub n plus 1 would be the next term, is equal to the current term plus a common difference. So in other words, to go from A3 to A4, you just add a common difference. Or rearranging that a little bit, we can say the common difference is any n plus 1 term minus the n term. So a sub n plus 1 minus a sub n. The difference between those two is always going to be the common difference. So two different ways you can write it recursively. But as always, let's see some examples here. And I'm going to show you a couple of different ways to work the examples, depending on whether you like we're talking about, whether you like to use this formula or this layout for the formula. So here, we want to find the nth term of the arithmetic sequence, and we want to find the formula for the nth term, which is the general term, and they tell us that the common difference is 3, and the first term is 2. So right away, that tells us that a sub 1 is 2, a sub 1 being the first term, and d is 3, being the common difference. Now, the method I prefer, which is using this equation, says that a sub n is simply the first term plus n minus 1 differences. And when I substitute in what I know a sub 1 and I know d. So I'm going to say a sub 2 is 2 plus n minus 1 times 3. And then distribute and clean it up a little bit, and we get a sub n is 3n minus 1. So that would be the rule to jump to whichever nth term you want. So the 100th term in the sequence is going to be 299 because 3 times 100 minus 1 would be 299. With method 2, you first have to calculate the value of c. This is why I prefer the method 1, but still most books will show you this method where you calculate c as being the first term minus the difference, and then c is going to be 2 minus 3, which is negative 1. And then you plug it into the formula here, dn plus c. And of course that gives you, now remember that d is 3, so substituting n, and a sub n is 3n minus 1. You're going to get the same value, but you just have that little extra step of calculating c first. So whichever method you prefer, that's fine. You can go with that. Either one works. All right, let's look at another example. Let's say we wanted to find a particular term of an arithmetic sequence. So they're showing us a sequence here, and they say find the 13th term of this sequence, or of this arithmetic sequence. The fact that they told us it's an arithmetic sequence is very important, because now we know how it fits the model. So here we're going to say that a sub 1 is going to be 2, that's the first term. And to find d, the difference, I can simply subtract any two consecutive terms. So whether I do 14 minus 10, or 6 minus 2, or 10 minus 6, doesn't matter, we're always going to get 4. So here, a sub 1 is what that should be, is 2, and the common difference is 4. So if I use the fact that a sub n is the first term plus n minus 1 differences, I substitute into that. And if I want the 13th term, now I just replace n with 13. So it's going to be 13 minus 1 is 12. 12 times 4 is 48, plus 2 is 50. So the 13th term is 50. Once you have the model, you can just simply substitute in the value of n to find which term you want. For writing terms, let's look at writing the terms of an arithmetic sequence. Now here they tell us that the fourth term is 20, the 13th term is 65, and they want us to write the first several terms of the sequence. They want us to be able to show how the sequence begins and how it continues. So the idea here is we're going from the fourth term to the 13th term. It means that we're going from 20 to 65. So we think of this as a sub 13 is going to be a sub 4 plus 9 differences. To go from a sub 4 to a sub 5 would be 1 difference. To go to a sub 6 would be 2 differences, etc. And this is why I like to think of it visually with that type of structure. So we have, and the question you really want to ask yourself is how many differences are there between the 4th and 13th terms? So if you do 13 minus 4, there are 9 differences. Matter of fact, you take the difference of the nth terms, and that's how many differences are going to be between them. And if you now can identify that a sub 4 is 20, a sub 13 is 65, putting into this equation, you're going to have 65 equals 20 plus 9 differences. So solve that for d, and you're going to have d equals 5. Therefore, you're going to have the following sequence. If a sub 4 was 20, then we're subtracting 5 each time. But we know a sub 4 was 20, so 5 less than that, 5 less than that, 5 less than that, and this way we're going 5 more. We can see that this is going to be the first several terms. Now let's look at something where we're using a recursive formula. So recursively, they're asking us here to find the 7th term of the arithmetic sequence whose first 2 terms are 2 and 9. Well, right off the bat, that is going to tell us that the difference is going to be 7, because 9 minus 2 is 7. So to find the nth term, we could simply note that, let me bring that up. We could simply note that the c, that value that they were looking for in the book, is a1 minus d. We know a1 is 2 and the difference is 7, So c is going to be -5. And then we can write an equation. The dn minus c turns out to be 7n minus 5. And therefore, when we put in the value that we're looking for the 7th term. So therefore, a sub 7 would be 7 times 7 minus 5, which would be 44. You're going to have to come back. All right, for the next one, we're looking for, again, a recursive formula. So here we're looking for the 8th term of an arithmetic sequence, and, the 8th term of the arithmetic sequence is 75. The 20th term is 39. They wants to find the first term and the common difference, but they also wants to find a recursive formula for the sequence. All right, now we should think about it this way. We have a sub 8 is the first term plus 7 differences, and a sub 20 is the first term plus 19 differences. So one way we can do it is we have a system of equations here. If we subtract the two equations, we cancel out the a's. That gives us that -12 times d is 36, so d is -3. And once I know that, then I can say that, well, a would be 75 minus 7d. If I take the first equation here and solve it for a, I get 75 minus 7d, substituting in -3 for d, and I get a is 96. Therefore, a sub 1 is 96, and recursively, we could write this as a sub n is a sub n minus 1 minus 3. In other words, to get any term for the sequence, you simply subtract 3 from the previous term. So that's one way we could write it recursively. As a side note, we could also say that a sub n plus 1 would equal a sub n minus 3. That would be really saying the same thing. And just to give you an alternative way, we could have used the fact that a sub n equals a plus n minus 1 differences, and then using the a sub 1 being the 96, the value of d being the -3, we could have came up with a general term as well, just to show you both ways we can do that. So here's your general term, and here's your recursive formula. They will both work in order to find terms in the sequence. All right, let's look at the sum of a finite arithmetic sequence. So if your sequence is arithmetic, then you can find the sum of all of the terms for that finite sequence by using this formula. And that's the sum of the n terms is going to be n is the number of terms you have divided by 2 times the sum of the first term and the last term. A sub 1 would be your first term, a sub n would be your last term. And when we get to math induction, we'll show a proof of this, but for now we're just going to use the formula. And let's take a look at how we're going to use it. If we have the following sum, we have 1 plus 3 plus 5, etc., all the way up to 19, and they want us to find the sum of that arithmetic sequence. Now, yes, you can just add them up the way they are, but the idea is we're trying to find a way to add a lot of numbers, so we're going to use the formula here. So using the formula, we have the fact that n, we can count that we have 10 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 different terms. So n is going to be 10. A sub 1 is the first term, which is 1. 19 is a sub n. I'm sorry, a sub 1 is 1, and a sub n, the last term, is 19. And then when we evaluate that, 1 plus 19 is 20. 10 divided by 2 is 5, so 5 times 20 is 100. So those terms all add up to 100. The next one is add the sum of the integers from 1 to 100. Then that would be a lot harder to do manually. So if you think of, again, the same formula, we have the number of terms. Well, from 1 to 100, there are going to be 100 terms. So it's 100 divided by 2, which is 50. The first term is a 1, or actually right here, first term is a 1, last term is 100. So they add up to 101. So 50 times 101 is 5,050. And we're going to see, when we do our proof of this, we're going to see a nice little historical problem using Carl Friedrich Gauss. Alright, next we're going to find the sums of the n terms of an arithmetic sequence. And here we're going to look at the sequence that has this general term, 3n plus 5. And from n sub 1 being, from n being 1 means that our first term would be 8, because 3 plus 5 is 8. And we want to find a way to express the sum no matter how far we go in the sequence. So we want to come up with a formula, basically. So again, we're going to use the same idea that our initial term is, our first term is 8, our last term is 3n plus 5, and the number of terms we have would again be n. Because this is what we get when n is 1, this is what we get when n is 2, when n is 3, and we're going to go all the way up to whatever n we want. So thinking about it this way, we realize the first term is 8, the nth term is 3n plus 5, so putting into the formula, it's simply going to be n divided by 2 times the sum of 8 plus 3n plus 5. And when we clean that up a little bit, 5 plus 8 is 13. We could distribute if we want, or we could leave it in factored form. Either way, there's a nice, neat formula to find the nth term in this sequence, regardless of which term we want. So if you want the 100th term, you plug in 100 for n, and that'll give you the value of the 100th term. Okay, finally is partial sums. Let's say we want to find the 150th partial sum of this arithmetic sequence. Now, for this, we can go pretty much straightforward with our equations. We're going to use the book way of doing the formula. So we should recognize that, of course, a sub 1 is 5. That's the first term in the sequence. The difference is going to be any of two of these subtracts. So 16 minus 5 is 11. So to go from 5 to 16, we add 11. To go 16 to 27, we add 11. So our difference is 11, common difference. So C is simply going to be A1 minus D, which is 5 minus 11, which is negative 6. And then, to find the nth term, we're going to use the dn minus C approach. So it's 11 times n minus C, I would say plus C, and that's plus a negative 6. So this gives us a formula for the nth term, which is our general term here. So if we want to know the 150th one, then we just simply need to know, if we want to know the partial sum, means we're adding all the terms up to the 150th term. In order to do that, we need to know how many terms we have, which is 150. We need to know what the first one is, which is 5. And we need to know what the 150th term is. That's why we needed the general term here. So A sub 150 means we replace n with 150. Sorry, excuse me. And of course, when we run the numbers there, we're going to get 1,644. So we put that into our nth partial sum formula, and we're going to find that 150 over 2 is 75, and then times the sum there means we're going to end up with 123,675. So anytime you want to find the sum, or that is the partial sum, you simply need to know the first term, the last term, and how many terms you have, as long as it's an arithmetic sequence. And we're done.